Okay, so where we left off in the last section of the video was we were working on some simple conversions within the English system, and those are pretty straightforward. Most of us probably know the conversion factors already. And before getting into the metric system, though, I wanted to show some simple versions of conversions that might require more than one step. As it says here, in theory, if you have the right conversion factor, you can do any conversion in one step. But for instance, in this case, how many inches are there in 17 miles? You would need to know how many inches there are in a mile. And I don't. You could probably look it up somewhere, but why waste time on that when you can basically just resign yourself to, in some cases, to using more than one step and using conversion factors that you know or that are easy to find, and then you can get the same answer. Also, when using more than one step, there are, well, actually, even when using one step, actually any given conversion, there's probably a more or less infinite number of ways that you could actually perform that conversion and still get the correct answer. So for any conversion, there's really no one way to obtain the correct answer. As I'll show you in this case here, how many inches are there in 17 miles? There are different ways to do that. And those different ways can potentially, give you a perfectly valid and correct answer. We usually try to aim for the fewest steps possible, just to save time and effort, but I wouldn't mark you wrong if you used more than the minimum, necessary number of steps. So let's see, if you want to go from, you're starting out with 17 miles, and you want to go to inches. In a case like this, you might want to just think about basically what becomes between those two units in magnitude. I don't know how many inches there are in a mile, but I know how many feet there are in a mile. So maybe you could go from miles to feet to inches. Then you can do it, you're doing in two steps, but you're using conversion factors that you know that are commonly available, and you'll get the right answer anyway. So we can go from, and they actually, this is a good way to lay things out too sometimes, just so that you don't forget, where you are or what you're doing. Just sort of lay out the units. I'm going from miles to feet, and then from feet to inches. And you can do it more than one step. So if I've got 17 miles, my first stop is going to be feet. So my first answer is going to be how many feet are there in 17 miles? Again, you're going to consider 17 miles to be in the numerator of a fraction divided by 1. And you're going to consider the same for the answer in feet. For the conversion factor, it's obviously going to be the relationship between miles and feet. If you have miles in the numerator for the measurement you're starting with, then you want miles in the denominator of the conversion factor. And if you want to end up with feet in the numerator of the answer, then you want feet in the numerator of the conversion factor. If you look it up, or if you know it, 1 mile is 5,280 feet. So that means 5,280 over 1. Okay, so now as we notice, the miles will cancel. Miles cancel with miles, and we end up with feet, becoming feet. And we have 17.0 times 5,280, and that gives us 89,760. Okay, in this case, that would be too many significant figures if this were the final answer, but it's not the final answer, so we can keep the entire number for now. Okay, so second step, 89,760 feet will be our starting point, and we'll have a conversion factor, and then we end up with something in inches. Again, the starting quantity can be considered to be itself over 1, 89,760 feet over 1. And the answer in inches can also be considered to be in the numerator divided by 1. And for the conversion factor, we're going to want the relationship between feet and inches. Of course, 1 foot is 12 inches. But remember where we place them. If feet is in the numerator, then we want feet in the denominator of the conversion factor, so they'll cancel. And we want inches in the numerator, so that's what we get as the answer. And then don't forget the numbers. It's 12 inches for every 1 foot. All right, 12 inches for every 1 foot. So now feet will cancel out. We'll end up with inches as the unit, which is what we want. And numerically, it's just 89,760 divided by 12. Again, you could ignore the ones. And of course, this is going to be a really huge number. 1,077,120. That number there obviously is way too big, and way too big, that is in terms of significant figures, because looking at these numbers here, we have, and remember for significant figures, you go all the way back to the very beginning of the problem. So we got 3 significant figures in 17.0, 5280, and 1. That's a conversion factor within the English system of measurement. So those numbers are exact, so that's infinite significant figures. And 89,760, if you don't use a decimal point, is 4 significant figures. Here we have 4 significant figures starting out step 2, 12 inches and 1 foot. Those are both exact numbers because it's a conversion factor within the English system, so that's infinite. And for the answer, that means among all of these, the smallest number is 3. So we should only have 3 significant figures in the answer. So that means 107 can stay, but everything else has to go. Notice that the first number we're dropping is a 7. So the last number we're keeping has to go up by 1. And also notice that all of those numbers are before the decimal point. So you have to replace them with zeros to maintain the magnitude of the number. The decimal point would be at the end. So 108 followed by 0, 0, 0, 0. Now, as I said when we were going over significant figures and scientific notation, when you write 1,080,000 with no decimal point, it's ambiguous how many significant figures it has. The fewest it could have would be 3, which is normally what we would assume it has, and that would actually be the correct number of significant figures. So writing this as your answer would not be wrong. But this number is ambiguous, as it could have 4 or 5 or 6 or 7 significant figures, depending on how accurately you actually know the number, or how accurately you knew the measurements that went into this number. And so it would be better, especially with big numbers like this, to write it in scientific notation, in which case it would be 1.08 times 10 to the 6th. Because if you start with a decimal point at the very end and move the decimal point 1, 2, 3, 4, 5, 6 spaces, you get 1.08. That is a number between 1 and 10. And you move the decimal point 6 spaces in the direction that made the number smaller. So the exponent has to be bigger than 0, which is what you started out with. And so it's positive 6. Also, 1,080,000 is a pretty big number, so that would indicate a positive exponent. Okay. There are, even if you use the same conversion factors, there's more than one way to do a conversion like this, because it's possible that you could string the steps together. I did this as an example in two explicitly separate steps. I went from miles to feet and then from feet to inches, but there's no reason that you couldn't just put in your first conversion factor, at which point the units effectively become feet, and then just go directly to your second conversion factor where the units effectively become inches, and then just multiply through the entire thing and you have your answer. That would be done like this: 17.0 inches, or sorry, miles. And again, we think of that as being over 1. And the first conversion factor brings us to feet, miles to feet. Whoops, miles to feet. And that would be 5,280 feet for every 1 mile. At this point, you'll notice that miles cancel. Miles here and miles there cancel. And you would end up with feet as the unit for the answer if you stopped here and wrote the answer down, but you don't have to. You can keep going. You've got a number that's now in feet if you multiply all of this together. And you can change feet to inches just by putting in, multiplying that by 12 inches for every 1 foot. Now feet are on the top and feet are on the bottom, so feet cancel. And the only unit here that doesn't cancel would be inches. And so you have that as the unit for the answer. If you multiply out 17 times 5,280 times 12, you get, well, 1077120, which rounds off to 1080000. That one, right. Or 1.08 times 10 to the 6th. Because that's essentially what we did up here. We multiplied by 5280, and then we multiplied by 12. It's just that up here, we stopped and wrote down the number before multiplying by 12. But you don't have to. You can just keep going. This times this times this. Ignore the ones because they don't change anything, and you get the same number. So it might be better if you're new at this, or if you're a little shaky, it might be better to do it the first way, because it's kind of easier to think of things as one step at a time. And then if you're a little better at it, or when you eventually get better at it, you can do it all in one step like this, and you'll have it. Also, as I mentioned, if you have, well, depending on which conversion factors you have or want to use, there's practically an infinite number of ways that you can solve any of these problems. And so I'll show you, just for fun, an alternate solution to this problem, just to prove that you can do it in any number of different ways. If you had 17 miles, let's go to the units first. If, for instance, you knew how many yards there were in a mile, you could go from miles to yards to inches. That's not very difficult. 36 inches in a yard. And as it turns out, there are 1,760 yards in a mile. So sure, why not try that? Okay, 17 miles. And we're going to consider that to be divided by 1. And if we want to convert to yards, we're going to need yards on top of the conversion factor and miles on the bottom. and it's 1,760 yards for every 1 mile. Now, again, like before, you could stop here and write down the answer, and then go on to the second step explicitly, or you can just keep going. Since we've already seen the two-step approach, I'm just going to keep going. If we want to go from yards to inches, well, you're going to need yards on the bottom, so they'll cancel, and inches on top. And of course, it's 1 yard for every 36 inches, or 36 inches for every 1 yard. So yards will cancel, and we are left with inches. And if we multiply 17 times 1,760 times 36, we get 1077120, which rounds off to 1080000, or 1.08 times 10 to the 6th. Okay, so like I said, many different pathways to the correct answer. The next major thing that I would like to do with unit conversions is the metric system. Conversions within the metric system. Okay, because, oops, they're important. They're much more common than conversions within the English system in science, anyway. And conversions within the metric system largely depend on knowing the values of the various prefixes. So, you have a table of the prefixes in the book, and also the one that I gave you. And so it's important to keep that handy. I'm not requiring you to memorize them, but keep them handy, get some experience using them. It's important to get comfortable in using them in unit conversions, and how to enter the values into the equation in order to get things to come out correctly. In addition to the prefixes, there are some useful definitions within the metric system, and they include the fact that 1 milliliter is equal to 1 cubic centimeter. So milliliter is the commonly used unit for small volumes in the metric system. But in the SI subsystem of the metric system, we tend to treat volumes as length times width times height, which would be some length unit like meters or centimeters cubed. And so if you end up with something in length units cubed, if you can convert that to cubic centimeters, that's the same as milliliters. And vice versa. If you get something measured in milliliters, but you need something, but say you need cubic meters in order to use that number in an equation, because that's cubic meters is the SI unit for volume, then you can just go from milliliters to cubic centimeters and then to cubic meters. Also useful is the fact that 1 liter is equal to 1 cubic decimeter. Decimeter is 10 centimeters, or 1/10 of a unit, or of a meter rather, and it's maybe about that long, 10 centimeters. And if you have a box that's about 10 centimeters or 1 decimeter on each side, length width and height, that's 1 liter. This is also useful because liters is the most commonly used measurement for larger volumes in the metric system. But again, cubic meters is the SI unit for volume. So if you get a volume in liters, you can always change it to cubic decimeters because it's the same thing, and then go from there to cubic meters. And we'll see a little later what to do with units that are raised to a power. Okay, like I said, conversions within the metric system depend mostly on the values of the prefixes. And so we can look at a few of those now. The base unit in a conversion will normally stay the same, and it's just the prefixes that are going to change. Start with something really simple. Say we could convert 150 milliliters to liters. If we're starting with 150 milliliters and we want to end up with something in liters, we can consider both the initial and final measurements as being divided by 1, to show that they're in the numerator. What we need now is the relationship between milliliters and liters. Well, this is easy enough because one of the prefixes has one of the units has a metric prefix and the other one doesn't. Milliliters versus liters. And so milli literally means 1/1000th of a unit. So 1 milliliter is equal to 1/1000th of a liter, or 0.001 liters. 0.001 liters is the way that I would prefer to write it because that fits easier into a numerator denominator situation. You can always get that if you don't already know. You can always get that by going to your calculator and just taking 1 divided by 1,000, and you get 0.001. All right, so in our conversion factor, we're going to want milliliters in the denominator and liters on top. We already know 1 milliliter is 0.001 liter, and there you go. Milliliters now cancel, and it's going to be 150 divided or times 0.001. And that will be 0.150 liters. For significant figures, notice that 150 milliliters has 3 significant figures. Now, looking at 0.001 over 1, you might be tempted to say, oh, 0.001, that's only 1 significant figure. Or you might be tempted to say 3 if you've forgotten that zeros at the beginning of a number never count. But it's a conversion factor within the metric system. And so those are considered exact numbers, and that is infinite significant figures. So remember, conversion factors within the metric system, in other words, the values of the prefixes in the metric system, have infinite significant figures. And so the answer should have 3 significant figures, which just happens to be what 0.150 has. Remember, the 0 at the end counts because there's a decimal point. We could do some other metric conversions. And we will, but I see that we're at about 25 minutes right now, so I'm going to stop the second section, part B, and we'll go into part C in just a moment.